Okay, let's get going again. Hello, my name's Simon Williams. I'm from Cardiff University and I'm a reasonably recent member of the IG committee. And it's my pleasure today to introduce Colin Swift from Brocade Communications. Colin tells me he's a systems engineer at Brocade, which he assured me means that he gets to go into customer sites, draw pretty diagrams on the board, and then run away to let other people do all the hard work. I suspect there's rather more to it than that. Colin's going to talk a little bit more about a real-world application of SDN, in particular in handling DDoS attacks. Okay? Thanks,
Colin. Good afternoon. You got my first slide? There we go. Oh, my font's changed. Okay. Good afternoon. My name is Colin Swift. I'm a systems engineer for Brocade Communications. My introduction is great. I'm great with marker pens and drawing diagrams and then running away and letting someone else install the equipment. As the title says, I'm here to give a brief talk about SDN, some of the technologies, and discuss some of its use cases and applications. I'll try and make some time at the end for some questions if we run out of time. My contact details are there. Feel free to email me or give me a ring and we can have a chat. So quiz time. Bit of audience participation. How many of you have had salespeople, like Mr. Samani at the back there, call or visit you and start talking about SDN in the last year? Lots of people, yeah. How many want it to stop? Yeah. So how many do you think actually understood what SDN is? Yeah, they're phoning up with this great product and saying, SDN, SDN, SDN. They stop talking about cloud. How many of them actually knew what it is? And how many of you were left wondering or more confused as to what it was? You know, I've had this big long hour phone call. Right, I'm not going to get that hour back. What was he talking about? So what we're going to do is we're just going to go back to basics and we're just going to have a quick review without talking or mentioning the word cloud. We're going to just dig into SDN and the real basics of it. So this is SDN in a nutshell. We've got a Pearson VUE exam for you at the end of this. So what's it stand for? Software Defined Networking. So there's a lot of different things. There's applications, there's servers, but I'm going to talk about the networking aspect of this and what it actually means. So we all know what a switch is, right? Got plenty of them just sitting in there day in, day out. Switches have got lots of different components, but fundamentally there are two kind of main functions within a switch. There's a control plane, which you've heard about, and there's a thing called a forwarding plane. Font's not done me any favours there, but anyway. So two main functions within a switch. I compare the control plane to the brain. It's the bit in the switch that does all the processing and the thinking and all the complicated stuff. That's it. That's a control plane. Forwarding plane is the muscles, it's the brawn. It's the thing that sends the packets to where the brain tells them they should go. That's it. That's a switch. That's what goes on inside. A lot of other stuff. Basically, that's it. So let's walk through the process of what happens. Your data comes into the switch, hits a control plane, and it says, where shall I send this? It makes a decision, and it sends that decision down to the forwarding plane. And the forwarding plane now knows where to send the data. Port 1, port 2. Really simple. So you all know how SDN works now. That's it. So what does that actually mean to us in real terms? What does that give us? Well, what if we were to take that control plane, or the brain, and abstract that and move it into a piece of software? What would that give us? Well, you're able to introduce new features into the network that may not be possible because of the hardware. They may be too expensive, or in some cases, not allowed. It's quite contentious. I work for a vendor. Sometimes we don't want you to have those features. So I'll explain why. So, feature requests. If you say to me, Colin, I had a dream last night, you call me in the morning and say, I've had this great feature request, it's going to really help us in our network. Can you speak to engineering for me? Try and get them to put it in one of our switches. And I'll say, yeah, of course I will. And I'll go away. And what I'll do is I'll take that feature request and I'll give it to my engineering team. And my engineering team will put that feature request with all the other thousands of feature requests that they've got in a queue. And then they'll look at that and say, well, what's our return on investment if we do this? How many engineers are we going to have to put on this? What's it going to take to develop that feature? What's our return on investment? You know, what do we get back for this? Sometimes they'll say, well, it's just too hard, it's too expensive, it's going to push other things out, you're not going to have it. And sometimes, and I'm being honest with you here, and we're not the only vendor that does this, we'll say, we don't want you to have it, because it compromises perhaps a strategy that we have. It may be a feature that's present on a higher end switch, so why do we want you to buy cheaper switches with this functionality in? It's what happens and it's what goes on. So the thing I really want to get onto here is, there's a term there, open. And you know, what is open? What do I mean by open? I think the single most important thing or decision that you must make with any hardware purchase going forward is anything that you buy needs to have an open approach to software-defined networking. So what do I mean by open? Well, anyone adopting an open standards is going to be able to truly adopt best-of-breed technology. You shouldn't be locked into a specific vendor, like Brocade, for example. Well, I won't mention any other names, but you know, we all know what's happened when proprietary protocols are being introduced into networking. It limits your choice. It limits your negotiating power. You end up paying more for your technology. So just remember that. You need to have an open approach to networking and the technology. Now, when the gentleman from Gartner got up this morning and asked how many of you have actually adopted SDN in your networks, I think I counted roughly from the back there 6 or 7 hands. So I'm just wondering, why is that? Why has it taken 2 years of this technology to kind of, you've got these people ringing you every day? Why are only just a handful of you adopting this technology? It's kind of about risk. That's the way I see it. You've got your networks, you've got your edge networks, you've got your core and your data center and your distribution layer. Why do I want to risk putting a new technology in there and start to play with it? It's because you need a technology that's going to give you the ability to adopt it slowly. So one of the issues you have with software-defined networking when you use a protocol like OpenFlow, for example, is you can't use, in a lot of cases, not all, you can't use OpenFlow on a port that's running your traditional networking in your environment. You've got to have one or the other. So then you've got a decision, do I risk it? Do I take parts of my network and just run SDN on them? Do I have a completely separate network? What if there was a technology that enabled me to use both? So what I can do is have my traditional networking, but then I can use OpenFlow at the same time on the same port. So we're not the only vendors that do this. There are a very small amount of us that do. But again, there's a takeaway for you. If you're looking at making any networking purchases going forward, even out to your commodity edge switches, make sure that it's able to operate in hybrid port mode. Otherwise, you're never going to be able to use SDN on it. And make sure that it's got an open approach to software-defined networking. So let's have a look at some use cases. You've had lots of people call you and talk about SDN. but really, what can you do with it? Is it just a core technology, or is it something I can use throughout my entire network? Well, it's your entire network. I don't see it as just a core technology. You can do pretty much anything you want with it anyway. You should be able to, at least. So let's have a look at bandwidth metering control. The amount of data that's going across your network, consider it. Do you sometimes wonder what data is going across your network? A lot of us do. But how many of you actually know what's going across your network in real terms? Or the scale of it? I'd say probably not many. So what if you could use some sort of analytics platform to look at that data going across your network and quantify it and meter it? And why would that be important? Why would that be an important function at your edge? Well, let's take something like a clearing day. You've got lots of students that are logging onto your network, accessing data, and you want that to be as punchy as possible. You want them to have a really good experience. So you've got all these things that are going on in your network. You've got Netflix, you've got Dropbox, you've got YouTube, iTunes, all sorts of things. Students with their average of 7 devices coming in and consuming all that bandwidth. Why not say, OK, we're going to be cruel to be kind. We're not going to shut this off. What we'll do for some critical hours is we'll just meter it down. We'll just lower the levels of it, put some quas in there, and then when clearing's finished, open the floodgates and let them at their YouTube videos again. But it's that kind of control over the data that this will give you. So what about open days? The reverse then is true. Don't care about people from the outside. Let them come in slowly, let them trickle in. But let the people that are coming in looking at that network, let them have a really good experience. Because it's about user experience. My son has just started college. First thing he said to me when he got home is, Dad, I went on the college network. I went on speedtest.net. I've got a 200 meg download and a 100 meg upload. Brilliant, that's the first thing he said to me. And I said, well, OK, that's better than home, a little bit, but you're not going to get that across 2,000, 3,000, 4,000 users. So again, it's having that visibility. But that's how users behave. They expect to get the same user experience in college, university, school, as you do at home. So giving that experience is key, because it's very competitive. People make their choices on which universities to come to based on the courses and the quality and the experience that you get in the university. Another use case. So in the heart of your network is a security appliance called a firewall. We've all got them. You might have more than one. You might have lots of them, but they're quite expensive. And what you generally do when you buy a firewall is you say, I've got a 3 or a 5 year return on investment on that firewall. I'll buy it. And my budget says that I'm going to replace it in 3 years. So when you purchase a firewall, you say, well, I'm not going to replace it for another 3 years. I'll build in the capacity of growth that I'm expecting, which may be 10, 20%. But I have to have that for the next 3 years. So there's a massive overspend and an over-provision on your firewall. So this is quite a cool technology. You're able to steer traffic around your firewall. Sounds bizarre, that, doesn't it? Because you want all your traffic secure. But why not make the first couple of packets go through your firewall and get approved? And then once you've done that, steer that traffic around the firewall, because it's persistent traffic. It's not suitable for all use cases. You don't want it for all user traffic. But what if you've got 2 storage head units talking together? They're doing lots of snap mirroring. There's a sustained long transfer for a long period of time. Why should that go through your firewall and consume CPU cycles? Because all it's doing is it's consuming bandwidth, and it's part of that purchase that you made for that firewall. Yeah? And my favourite use case for SDN, it sounds bizarre, that, doesn't it? Layer 2, Layer 4 network attack mitigation using flow optimizer. So what does that mean? You can take any point in your network, and you can change the flow of that traffic or the destination of that traffic and do pretty much what you want with it. So take a denial of service attack on your network. You could take all of the DDoS traffic, strip it out from your existing traffic, keep all of the interesting traffic hitting your firewall. You're reducing the load on the firewall. I mean, let's face it, by the time an attack like that's hit the perimeter of your network, you're gone anyway, right? But why should the internal network suffer? Why should that firewall be overloaded? Why should that CPU get to 90% and stop processing? So this kind of saves the day, and it's a very cost-effective way of achieving this. Don't forget, network attacks can happen inside your network, and they more frequently do, to be honest with you. It's inside your network. So you can identify source, destination, layer 2, layer 3 pairs, port numbers, all of that interesting information, and you can send that off to another unit for processing, or you can just black hole it. You can drop it and say, right, let's just get rid of it. You could identify a specific geo-IP. So if you've got traffic coming from different global locations and hitting your network, you know, why do I need a guy from Australia? Why is he hitting my network? Why is he consuming bandwidth? Where we don't have a presence out there for a specific time, maybe on clearing day. Let's take all of those geo-IPs that I don't want and just send them to a holding page, send them to another system. I mean, say you've got another organisation that's part of your university that's in a different country. You could send them to a cloud service provider that's closer to them from a geo perspective. So you can start to do a lot of things with this kind of technology. So this is quite common. You have lots of systems in your network maintained by different departments. Can I orchestrate some of my processes? So what does that mean? Well, I'm going to talk about Workflow Composer. What is Workflow Composer? Well, think about all of those silos of different functions within your organisation. You'll have a sysadmin team, you'll have a network team, you have a security team, you have a storage team, and so on and so on. And they all have various levels of automation that they've achieved themselves. They may be homegrown or they could be external, but they've got these automated little processes that are going on in their silo. And that's great. You know, they're kind of getting there. But what if you could tie all of those together? What if you could say, right, cross-domain, I can start tying all of those individual automation tools that have been developed. So it sounds a really complicated technology to adopt, but it's not really. It should be turnkey. You should be able to just switch it on and have some inbuilt applications that will just start working for specific use cases. But you should be able to customize that. You've got all these different bespoke systems that people have developed. You should be able to tailor some sort of automation that will tie them all together. And you should be able to do it yourself. I mean, you guys have got some really clever people in your organisations. A lot cleverer than us sometimes, most of the time. But you could do it yourself, and we also have other people that can come in and do it for you. So how does that work? It's really simple. You have a set of integration points, and those are just sensors. syslog, SNMP traps that come out of network devices, S-flow information. And then you have some actions and integration points that talk to the actual hardware or the devices. That's logging in using CLI. That's YANG, REST APIs, netconf, all of those protocols that you use to talk to devices. And then you have the important bit, which is the workflow composer, or workflow engine in the middle. So what does that mean to you? Well, I said before, automating silos is not enough. What you want to do is bring those teams together. This is a really interesting statistic. 90% of the total time used to complete business tasks is classified as transfer delay time, and 10% on the actual task. What's going on here? What are they doing? That's 90% of hot air. Nothing's happening. I don't like this person. I'm not talking to him. I've got a change control meeting I've got to go to, this doesn't work, we've got something else to do. That's costly to you. You pay for that. 90% of the time, to do a task is just nothing. 10% is the actual task execution, where stuff is actually going on. Those animations. So Workflow Composer, cross-domain workflows and eliminate transfer delay and reduce workflow execution from weeks or days to just seconds. They really do. They can take a lot of those complex tasks down to minutes or seconds. Almost done. So let's discuss one use case. There are many. This is my personal favourite. So, 2 a.m. calls. You've got a guy sat there asleep in front of a service desk screen in one of your buildings. Or he's at home, or she is at home, asleep at 2 a.m. And you have a switch failure. BGP failure, switch link goes down. So the switch sends out a syslog message. And then the Workflow Composer matches that error message. It triggers a BGP troubleshooting workflow. So it says, right, I've received that syslog message. I've already got a workflow. I already know what to do with it. Now, someone's configured that. It's predefined actions. So the action extracts information like switch IP, BGP peering address, egress interface, all of the technical stuff that your service desk guy would have to do in the middle of the night at 2 a.m. So then the interface is transitioned. You bounce the interface. Disable it, bring it up again, ping the peer address. Is it routing again? But it also creates a help desk ticket automatically with outputs from the above. So you've already got a level of diagnosis, and that's been completed in less than a minute. Then Workflow Composer initiates a workflow, initiates the fact that an interface could not be restarted. It creates a help desk ticket, gives it an ID, gives you the URL. It posts a message to Slack so the NetOps team can have a look at it. And it launches an incident to PagerDuty to notify the operator. So what we've done is we've taken something that would normally happen at 2 a.m. and it's turned it into a 10 a.m. follow-up. I mean, again, it's all about resource. Just think of that guy that would have normally been processing that at 2 a.m. He's been up all night, he's half asleep. That's him gone for the day, really. But what you've achieved is a help desk ticket, some simple remediation, and it's just using a standard message that comes out of a piece of kit that you've got in your network today. You've created a little bit of a script that reacts to that and a set of actions. And that's really what Workflow Composer is about. It's bringing all of those different tasks together. It's a simple use case, but it's very effective. We're down to kind of less than 5 minutes there. Short and sweet. I'll finish there. So thanks for listening. Any questions? Everyone's quiet. Okay. If any of you think of anything that you'd like to ask, my email address is there, my contact phone number. Please feel free to contact me direct. I'm ready to talk. We're on the stand down below, so thank you for your time.